In this problem, we're asked to sketch the polynomial y equals negative x to the fourth times the quantity x minus 2 to the fourth times the quantity x plus 4 to the fifth. The first thing that we need to do sketching a polynomial like this is we need to figure out what our power function is. Our power function is kind of like our parent graphs from previous graphing sections. And that's going to be, for this problem, y equals negative. We'll include the coefficient out front. And then let's see, I need to figure out how many x's would be in the very first term, or the most powerful term. So it'd be x to the fourth times another x to the fourth. And here times x to the fifth, that would be the biggest term. So we would have an x to the fourth times another x to the fourth times an x to the fifth, making up all of the most powerful factors in each part. That gives us a grand total of, let's see, add the exponents. 4 plus 4 is 8. 8 plus 5 is 13. So we have y equals negative x to the 13. Okay, that tells us what our graph is going to look like on the far left-hand side and the far right-hand side of our graph, but not so much what happens in the middle. These graphs, let's see, since x to the 13 is an odd exponent, it's going to resemble an x cubed graph. And since there's a negative in front of it, it's going to have a reflection. So this graph will look something like this function. Okay, so I don't know what happens in the middle here, but I know that my graph is going to be going up on the left-hand side and down on the right-hand side. It's the middle part that I'm not sure about. Okay, to figure out what happens in the middle, we need to figure out what the zeros are, or the x-intercepts. And we need to examine their multiplicity of each x-intercept and each zero, so that tells us what kind of intercept we have. Do we have a bounce intercept, or do we have a through intercept? So let's look at each one of those. Our first intercept, or zero, will be x equals 0. That's our first one. So we'll have x equals 0. This has an even exponent with it, so it has a multiplicity of 4, which is an even number, so it is a bounce intercept. So at x equals 0, I'm going to just remind myself I have a bounce intercept at x equals 0. The second intercept I have is x equals 2. So at x equals 2, I also have a multiplicity of 4. I also have a multiplicity of 4, which is, again, even, and is another bounce intercept. So let's see, x equals 2, and we have another bounce intercept. And then finally, x equals negative 4 is our last intercept. That's way over here. That has an exponent of 5, multiplicity 5, which is an odd number, so this will be a through intercept. So x equals 1, 2, 3, 4. And at negative 4, I have a through intercept. So when I'm going to sketch this curve, I need to start in apparently the upper left-hand corner, pass through negative 4, bounce off of x equals 0, bounce off of x equals 2, and end up down in the right-hand side. So I'll carefully draw that graph. So start in the upper left, coming down through x equals 4, bouncing off of 0, bouncing off of 2, and ending up in the lower right. Don't know how far down these two values go. We could figure that out by plotting some points or using calculus in a later class. For right now, this is a pretty good rough sketch of this polynomial.